This session is about Brainhat save sets. A save set is the whole context or a portion of the context set aside and resurrected later. It can be used to save sessions, to create memories, or to trade parts of the context with other copies of Brainhat. Command line options affect the way that Brainhat runs. It tells it whether it's going to be restoring or saving memories, storing or saving a whole context, or working with layer 4 memories or level 4 memories, which are actually like scripts. We will talk about those in detail in a future session. For now, I'd like to go over, log into my brand new terminal, start a copy of Brainhat, and take a look at some of these flags and what they do. I'm going to start with the script, run. I have a copy of Brainhat running. I think I'll bring you in close so that you can see it better. Here we are. We've talked about the context in the past. I'm just going to look at it again as a refresher. I'm just going to enter a few things here. Let's say dogs like bones. Sky is blue. Mario loves the princess. We can go into debug and we can examine the context that we have developed so far. I'm going to do this with the xspeak1 command, which translates the data structures in the context into simple English so that we can understand what we're looking at. This is what the beginning of the context looks like. You can see the facts, propositions that I manually entered just a moment ago, along with a record of the fact that I said them. What I want to do is take this context, or start over again and take a context just like this, save it, and then restore it in a future session. So let's do that. Oops, I have to type that quickly. I'm going to use the -S flag. I'm not going to use the run script. I'm going to invoke Brainhat by hand here on the command line. With the -S flag, I'm going to save the session in a memory subdirectory in a file called blart.mbin. Blart means nothing. I'm going to use the repeat flag so that Brainhat will echo the things we put in. It just makes it more interesting. What did we say before? We said dogs like bones. The sky is blue. And Mario loves princess. I'm going to exit in the normal way. You can see there are some hash marks. The hash marks are an indication that something was saved. In this case, like I said, we're doing a whole session. So we're going to restore a whole session. Let's see how that's done. Just going to start Brainhat again. And use the -R flag. Same arguments as before, except for the restore. Now we're going to go back and look at the context the way we did before. And there it all is. That was the -S flag to save a whole session, and the -R flag to restore a whole session. The context is organized temporally. That is to say, the newest things are at the very beginning of the context, and as you work your way backwards, there are older things. Everything is hashed, everything can be retrieved. When we save a whole session, we're saving the whole context, and we're saving it in order. This is what the context sort of looks like. Dogs like bone, sky is blue, Mario loves the princess, proceeding from new to old. In order to save this whole session, what we have to do is package up the context. We also package up a discourse buffer and we package other state information so that when Brainhat is resurrected with this save set, it will be in the same place as we left it. This is basically what a save set looks like on a disk. It could change, but it's some information about versioning, about the contents, a little bit of text to keep track of things if you like. The context, a copy of that. Context discourse buffer. That is to say, discourse buffer is a record of things that were said. Context is a record of things that are known. These may be very different. And dynamic symbols. We haven't touched on that, but dynamic symbols are for symbols that aren't part of the startup vocabulary, such as names. Let's go back here. The first thing I want to do is demonstrate the -1 flag. This is for layer 1 or level 1 memories. Level 1 memories are basic facts about basic things. You can imagine that whenever you're programming a session, you don't want to have to include every little possible nuance about everything. You'd rather be able to mine, farm, borrow facts from other copies of Brainhat or from save sets that you have nearby. Otherwise, everything you're starting from first principles. Let's try that, this -1 flag, to see what we can do to record basic information and make it available for the next session. So we're going to start again. I'm going to use the -1 flag. I'm going to use, actually, let me do something first. I'm going into memories, and I'm going to clean it up so there's nothing left from the last session. I don't think there is anyway, but we're going to do it. Brainhat. Clear line, so you can say dot/Brainhat -1 plus repeat. All right, let's enter some basic stuff. Bananas are yellow. Seems good. Sky is blue. Dogs like bones. And that's a short session, but good enough. You can see some hash marks. You also see a message at the start of this session that says starting new memory hash. All memories are hashed. Saved sessions are not, but everything we do from now on will be hashed such that a memory can be restored based on its similarity to things that are going on in the context at the present time. The memory hash is cumulative. Between sessions, it will keep adding. And in fact, you can actually restore memories and add memories at the same time. So the hash can be changing. Anyway, we did a -1. That means we saved some basic facts. Let's see what happens if we go to restore or use these memories. When we're going to use memories, we use a -A flag. That's auto recall. And it makes whatever memories are available to us. I'm going to do a couple little tricks in here while I'm there, but let's see, what color are bananas? All right, so it restored that basic fact. I'm going to say something here. I'm going to say sky is gray. What do dogs like? What color is the sky? Now, we clearly saved a memory that said the sky is blue, but it was overridden by a fact that was learned in a sort of a higher priority way. A fact that was learned in the discourse or during the operation of Brainhat is usually going to override a memory. So, in fact, in spite of the fact that the sky is blue was a ready answer in the memory, it was orthogonal in opposition to something that we already knew, which is that the sky was gray. And so that memory is discarded and doesn't get restored. That's layer 1 memories. I'm going to go back to memories, clear it out. Okay. Let's look at layer 2 memories. Layer 2 memories are basically inference templates. Inference templates, just like basic facts, are useful for deriving other facts from newly learned information. Inference templates in Brainhat can have 4 conditions and 4 consequences. We're going to make it pretty simple here because we're going to talk about inferences at some other point. But let's set something up. So -2, new memory. I'm going to enter a couple things. Here. These are basic facts that you know. Because a dog can't eat and sleep at the same time. And likewise, if a dog eats, the dog does not sleep. I'll try another one. Dog sees a cat. Okay. And you can see some hash marks. That indicates that we saved something. Now I'm going to invoke this the same way as I invoked it last time with the -A flag, which is for auto-remembering things. Dog. There's that. Now let's say that the dog eats. Now you can see that we have actually 2 propositions that are now in opposition to each other based on the inferences that we put together. Let's just see what it says. Does the dog eat? Does the dog sleep? And that's what happened. If I say, did the dog sleep? So this is just an interesting side excursion maybe. If a new fact is generated in discourse or by other processing in Brainhat, and it's in opposition with something that's already in the context, depending on its priority, it will push the existing information in the context, if it's in the present tense, into the past tense. It is possible that the dog ate and slept many times in the past, so you can have overlapping states, orthogonal states in the past tense, but you can't in the present tense. So we have, by virtue of the inference templates, said that sleeping and eating are mutually exclusive. We had another one in there. Okay, there we go. So those are layer 2 memories, and those are basically inference templates. They can have lots of substitution in them as well. Now I want to look at layer 3 memories, or vignettes. These are pretty interesting. These are the basis for implicit memories and implicit memory recall. So let's just do the things we did before and see what happens. Implicit memories aren't like these explicit inferences. Implicit inferences or memories are derived by similarities to events that were recognized as being similar to those in the past. So for instance, well, I'll just show you how it works. Let's do this. -V or -3, they're the same thing. These are layer 3 memories essentially, and they're implicit memories. Let's repeat. I was at the beach. The sun was shining. The weather was nice. I lost my dog. You can see a hash mark. Something was saved. I'm going to start this back up again, this time using the memories with the -A flag. The sun was shining. I was at the beach. The weather was nice. Did I lose something? That's an implied inference. They're a little tricky, But there's a lot of logic to make sure that implied inferences don't come into the context if they conflict with the past. We also treat stative statements differently than active verbs. Stative are the things you believe or you know. Active verbs are actions that one thing occurs on another, and we'll get to that sometime in the future. The next thing I want to address is the same kind of thing, layer 3 memories, except they're not done in vignettes or whole sessions like we just did. If you look at the context, assume that it's got hundreds and hundreds of elements in it. They can be saved periodically into little save sets, as you see in this slide, like save set A, save set B, save set C, that overlap. So some facts from one save set may be common to another save set, etc. Those overlaps can be used to tie them together, but it's also possible to make a long-running session be saved as little snippets that can be hashed and re-invoked later for implicit memories. If you have a long narrative, this would make perfect sense. You could learn an awful lot about the way everything behaves by reading enough narratives in this fashion. So I think I want to demonstrate this, at least to show you how the memories look when they're saved. So let's do that. I'm going to go back to the terminal. Not that one, this one. I'm going to take you into the memories directory briefly to look at a file. This is going to be the source of our memories. This is a transcript of someone who was learning English, writing in English. I found on the internet. And I made it so that Brainhat can read it and then discuss it. Let's first, just for fun, read it in as a whole save session, and then we'll cut it into little memories. There's a -C flag, which I can use to read whole input. There's multiple flags like this for different purposes, but we're going to use that. The name of the file is gabby.txt. And I'm going to save it in memories gabby.mbin. And let's see it go. This will take a minute. There's a lot of caching, but it's not turned on. Let's go back and see if it's done. Oh, I saw a hash mark. There, it's done. All right. Again, we looked at the input for this a second ago. Let's just do that again. Sorry about that. That must have been loud. Text. Okay. Get the idea. I'm going to restore that. Memories. Gabby.mbin. All right. This is written so that essentially the person that's talking to Brainhat is Gabby. I'm just going to ask it to describe me. Oh, there we are. That's my sister's name. Okay. What is my name? That's that. Now let's run this again. We're going to use the -t flag, which is going to take that whole text input and cut it into lots of little memories. I'm going to go into the memories directory and clean it out. Okay, and Brainhat, Brainhat, not it. -t, -c, memories, gabby.txt. Remember, this is the text file. I think that's it. We'll just let it go. If I go into the memories directory, these mbin files are all the little overlapped portions of the context that were saved in this run that we just looked at. And just for fun, I'm going to grab one and restore it, because it's just a save set. It just happens to be smaller than the whole context saved at once, so I can do what I'm about to do. Brainhat -restore memories. Oops. Thought I saved that. Let's see. Pay no attention to that man behind the curtain. Okay. Now let's see what we caught. That looks like a bug right there. Maria has a boyfriend. Maria did finish preparatoria, Tapachula. Maria did come back. Maria said Denver was an experience. These little memories are now available for restoration during a session. The session that restores them may have had nothing to do with Maria at all. And that's the benefit of taking large narratives, indexing them, abstracting them, and making them available for use in future sessions. I believe I'm done now. There was one other thing I did want to talk to you about. Let's see if I can get the useful slide back up. Yes, this is good. Okay. As I mentioned, there's a layer 4 or level 4 memory. That's called motives, and we're going to have a whole session on that all by itself. Level 4 memories are basically a script, a way to do scripted processing so that you can do very specific things inside of Brainhat alongside the more mushy sort of data flow things that happen with inferences, input, and output. Motives provide you a way to say, I'm in this state. I have a multi-way branch into multiple other states potentially, and I can progress from state to state. Why would you use it? You could use it if you're trying to, well, old-style expert system, except quite a bit smarter, to help somebody diagnose a problem, to sell some cosmetics, whatever you wanted to do that had sort of a state diagram associated with it. Level 4 memories are the way to do that inside Brainhat, so it's not just all fun and games and doesn't suffer some of the brittleness of systems like this are famous for. And so that's it for now. Thank you for watching this, and I'll see you next time.